everyone. I hope you like hardware demos, because there's a lot, and let's hope one of them works. So this talk is called Alt-Ctrl, Scream into this Arduino, because one of you is going to be screaming it into Arduino. I'm going to tell you about me first, in case you don't know who I am. My name is Rachel White. I'm a tech evangelist at Microsoft. This is my Twitter handle. Only follow if you like cats, because I post more about cats than I do about tech. And if you want to follow along with this talk, this is the URL that you can find it at. There's also other projects of mine on that site if you feel like looking. So I want to start this out by saying I'm not a great developer. And that's not an imposter syndrome or a hurtful thing, because I'm also not that great at hardware. It's just something that I really, really enjoy doing. And the reason that I'm saying both of these things is because I want to tell you how I'm really great at problem solving. I may not be able to recite perfect syntax for you about JavaScript or Node. I might not be able to tell you the specs of the actual microcontroller on the Arduino, but if you give me a set of problems, I can probably solve it for you. And I would much rather say this than have anybody call me a rock star developer any day. I also really like to break things. So usually people will be like, I never break anything. I have bug-free code in my production, but I love breaking things, because then it gives me an excuse to fix it and figure out what went wrong and how I can prevent from doing it again in the future. So I'm going to tell you about my first hardware project before we start getting into all of this stuff. I made an automated cat feeder robot last year. It's called RoboKitty. I used Node, Socket.io, and Johnny 5, and it was the first time that I had used any of that stuff. I had typically just been a JavaScript engineer before, working on MVCs and a lot of front-end stuff. No real intense server stuff, no hardware, nothing. It's a pretty cool cat feeder if you haven't seen it. And I also had absolutely no idea what I was doing the whole entire time. This is the URL for the repo, if you want to go check it out. But I'm going to show it to you really quick so we can see together. So as you can see, it got pretty popular. It was 726 stars. It's the only thing that I've ever open sourced, and my first open source project. And the reason that I'm showing it to you is because as somebody that had no idea what they were doing when I got started, I realized how easy it actually was when I broke it down into the smaller steps to put all the things together. So when I open sourced it, I made no assumptions about the end user or how they were going to approach the problem, and actually wrote out every single step from installing Node, installing CLI tools, and everything. And I'd like to think that because I was so in-depth and thorough is why it was so successful for me as a first project. That's the logo. I did that too. I have a degree in design. I'm not a computer science background person. And this is my fat cat, Rick. He really loved testing the feeder out to make sure it worked, especially when it didn't and it wouldn't stop dispensing food. So this was essentially my plan for RoboKitty when I started making it. I was like, all right, I'm going to push a button on a website. It's going to go to a microcontroller that is connected to the internet somehow, and it's going to turn a servo that makes food come out of a thing. And I just kept on breaking it down into smaller steps until I realized the tools that I needed to get the project done. So I'm going to take a poll of all of you right now. Who's worked with Node at this Node conference? Yay! That's great. Who's worked on hardware? Okay, that's a good amount. Who hasn't worked with hardware but is really into trying it out before? I hope there's more of you if you're in this panel. All right, cool. So, all right, we're going to talk about thought processes right now in terms of Node hardware. And I'm here to tell you that the hardware is the easy part unless you're demoing it in rooms full of people when it probably won't work all the time. The easiest part is taking diagrams that people have already made for you and just plugging it in and then understanding why that connection is happening. And the Node app that you're running, either if it's a micro computer on the device, or most of the time with the Arduino or other ones, you're going to just run it straight from your computer. That's where all the magic happens. That's where you write the information for where you want things to happen. And since more of you raised your hands about having experience with Node versus having experience with hardware, any of you can go home and do something like this later today. And also, this talk isn't going to be super technical. I'm not going to explain to you what jumper wires are plugged into certain ports or pins, or what a lot of this stuff is, but I'm going to show it to you and explain to you how I did all of these things. There's lots of demos. Hopefully they work. There's 4. So let's get started. I need one volunteer that I don't know. So who wants to yell? Oh yeah, I need a volunteer. And you must be good at screaming. I won't hurt you. Please, anyone? Okay, come here. No, well, I know you, but yeah, you, come here. All right, so first demo, please be good to me. I have it all queued up, so it should ideally work. So first, let me show you what we're working with. That's me. All right, so what we have here is an Arduino Uno, and it's plugged into my computer already through USB. And then I have a RGB LED that's hooked up to it. And then there's a little microphone there. So what we're going to do, actually, I'm going to hold it here so that you can see it. Hopefully I'm not too loud. We're going to hold that little microphone. Yeah, actually, I'll hold it up. Let me move my terminal out of the way. Good, we're not loud enough yet. So I want you to yell as loud as you can into that microphone, and it should make this RGB LED shout rainbows. Are you ready? You might want to cut my microphone off temporarily. All right, it worked. Thanks, that's all I needed. Yep. So this is a really simple demo, but the point is, it's still exciting and fun, even though it's only a microphone and an LED hooked up to an Arduino. You could scale that up and make something super impressive as an art installation or whatever you need. So now I'm going to talk a little bit about what is a microcontroller at a very brief level. So we have 2 different kinds up here. They're typically low-powered devices, about 3.3 to 5 volts. So sometimes you need external power to power some of the other things that you would be using with them, which I'll talk about in a second. They interact with sensors and modules to do something. What that something is, it's up to you. Usually it's one dedicated task, though architecture varies on certain models, so you could do more complicated tasks based on how many sensors or other things that you hook up. They're really, really great for logical operations, so pretty much like conditional statements. If X happens and it meets a certain condition, then do something else. So now we're going to talk about what are sensors. Sensors enable you to interpret that data that you're getting into the Arduino through various input methods. Today we're going to talk about the sound one, as we just demoed. Next we're going to be using a flex sensor. Then we're going to be doing capacitive touch. And the last one that I'm going to show you is a secret. So that'll be exciting. They're also an integral part of IoT applications. Most of the time you'll go on to Lifehack or the other site that people make things, and it's stuff that involves temperature, light, sound, accelerometers, potentiometers, GPS, RFID. It's a dangerous thing when you realize you're only really limited by what your brain can think of, because you go and you start getting into the hobby and you go to an electronic shop and you have a whole entire wall of sensors and you're like, sure, heartbeat monitor, lasers, this sounds great, we'll make something, and then you spent $100, but it's pretty cool. The possibilities are pretty much endless. So I'm going to show you an example right now of all of the sensors on Adafruit. You can see there's gas, barometric pressure, a bunch of other stuff. Pretty much whatever you want, you can get. You can make weather monitors, pet feeders, temperature regulators for your home. You can tweet from your toaster if you want, which might be kind of a fun project. Same sensors, like I said. And now we're going to talk about exactly how you achieve that stuff. Since we both know Node, I have good news. It's easy for all of us, because you can use Johnny 5. What Johnny 5 is it is a Node robotics library that allows you to interface with a whole bunch of different microcontrollers in an easier way, so you don't have to write any C or Python, whatever. It's great. There's also Tessel, which is out now, which is like the best if you're getting started, I think, in hardware and you don't really know what you're doing, because Tessel with Johnny 5 like just takes out a whole different abstraction layer out of what you would need to do with an Arduino otherwise. And I'm going to show you really quick. So the best thing about Johnny 5 is if you're at that hardware store and you're looking at the wall of sensors and modules and you're like, I want to do something with this, and you grab it, you can come here, and on the examples page, they pretty much have a ton of different kinds of sensors, and you could click on it, like let's do a proximity sensor. And then it gives you a fritzing diagram which tells you exactly how to wire it up and the code to run it. So being able to take a couple different versions of these and putting them together, you can really get far with it. And then here's some other projects that people have done with Johnny 5 on hackster.io, which is a pretty great site for hardware. Cool. Let's go full screen. All right, it's time for another demo. I'm going to show you how this flex sensor works. I have a picture of it up here. This demo is using the Tessel, and we have a flex sensor hooked up. I'm going to hold it up too so you can see it. Actually, I can't because the cord doesn't reach, so pretend you know what this looks like from the table. I'll hold it up a little bit. We are done with you. All right, so this is the flex sensor. Where's my laser thing? Okay, so these are dot star LEDs. There isn't that much information out about them, but luckily Cassandra Perch had started a project with them. And then I made my boyfriend, because I don't understand hex, figure out how to get it to work further. This is a flex sensor, and that's the Tessel, and it's all plugged in. And now, when it works, what it's going to do looking for your Tessel, connected to Tessel, building project, running, it's still white. Great, okay, so what's gonna happen here is when you bend the flex sensor, it's going to light up more LEDs incrementally because it's altering the stuff that runs through it. Wow, okay, so 2 demos out of 4 work, that's great. So, there's links on all these slides too if you want to try them out. And then Dust Mop, he altered it a little bit to get it to work with our case. And this is what the code looks like, half the code. There's still the dot star library that you need to include. It's not that many lines, and it's still really cool. Like, you could make so many things with just LEDs and a simple microcontroller, and people really love lights. I don't know why. It's easy to please. All right, another demo. So this one is pretty neat. There's a big part of a game convention called GDC, which stands for Game Developer Conference. And it's called Alt-Ctrl GDC, so I kind of stole the name of my talk from their interaction part. The cool thing about it is it all involves games that you don't use typical controllers with. So capacitive touch, which I'm going to show you right now. These are the little things. They're copper pads that are wired all the way into my chip, which is this thing right here. It's a 5-point capacitive touch sensor that I got from Adafruit. The input is all on this side, so you can wire it up to whatever you want. There's also an easier way to do this with something called a makey-makey, which this is essentially the same thing, but I'm not plugging it into like bananas or apples or other fruit that is conductive. So, I'm not showing you the code yet. What we're gonna do is we're going to play a video game. Connected. Running. The lights are on. Great. Uh-oh, one's stuck on. Oh, no, this is the demo. OK, cool. Zoom in. All right, we're going to play a one-player game. So I have each of these touchpads mapped to a different one. So I can walk. I can jump. I can run away. I can die. Let's try one more time. It's really hard, especially because I don't have it enabled so that you can use two at the same time yet. OK, I'm not going to do well, but it works. So the code for that's pretty awesome, and even easier than the other ones that I showed you so far. Oh, no, it's still touching the screen and advancing my slides. Hold on. All right. So what I did for this one is I'm using Johnny 5 and initializing the board, and then I'm using a library called Robot.js that lets you emulate things that you would do on the screen. So key presses, mouse movements, you can move a mouse along a certain wave or a path that you would want. And all it really is checking if I'm making that capacitive touch circuit completion, and then it's triggering the certain keys that I want to press, which are mapped to other keys in the emulator. So this would be a really easy way for someone to make a custom gamepad controller for whatever game or anything else that they would want. All right. So now I'm going to talk to you about biohacking. Biohacking is a niche field that intersects people that like hardware and people that like body modification. So this is a encapsulated RFID chip, and it's 13.56 megahertz. There's certain frequencies that you can get them to work on. And I have one in my hands right here. That's not my hand. Mine's much smaller, I guess. But yeah, the chip is right here. And you can do a lot of things with it. Like you can put your employee information on it. You can use it to unlock cars. You can put URLs on it and have people go to websites, have your business information on there. It's really interesting and easy. For this demo's sake, oh no, did I forget to? OK, it's an NVM issue. I know I'm using old versions. Don't judge me. Don't take pictures of the screen right now. Oh, no. What am I doing wrong? Oh, God. Oh, you're right, you're right. Yay! Thanks, Dustin. That's why I like you. That was the scariest thing, because this is like the most exciting one. All right. You're such a liar, Dustin. Give me 1 second. We have to get this to work, because it's the coolest. All right. Documents, repos, touch. Oh, wait, am I in the wrong? No, I'm in the right one. RFID me. Package.json has index.js. Index.js should be fine. Please work. TTY USB modem? Yeah? Oh, it's the wrong port. Here? I wonder, is it because the cable's different? Ah, see, the NodeBots community is so helpful. Yay, okay, now we're gonna see it. All right. Oop, can somebody hand me that box that's in this bag? This is such an interactive talk because I forgot some things. Cool, yeah, there's a RFID in there that's not in my body. All right, so I made this computer It's just a Node server running Express with some, cute credentials. This is the wrong resolution. Oh, whatever, we're not going to worry about CSS right now. All right, so I scan the RFID chip. It's not me. It says access denied, right? But I have it set up that if I scan the chip, it always takes like 15, there. Because I'm a hacker, and it's super cyberpunk, and then you get a little ASCII skull that says access granted. So yeah, that was easy if it works. So this was the code for that, except there's a different USB port because we used a different cord, so like serial port stuff is kind of finicky. Just a regular Express app, regular variables, setting up index.html, super easy on port open stuff. There is some C dealing with the RFID chip, but we're not going to worry about that. And then I'm emitting regular socket events. I'm not going to bother showing you the index.html that listens for that because it's just some styling and variables. But yeah, it was easy, right? So now I'm going to give you some resources if you want to get a little bit more familiar with Node, and all these links are in the slides. There's Node School, which is great. There's NodeBots, that's great. There's Johnny5.io, which is amazing and has so many good resources for people that want to learn. There's an amazing book that a bunch of people here that have contributed to. And there's also Cass's book, which is great. These are links to the Amazon stuff. And then I'm going to leave this up because all these people are really awesome if you want to take a picture and follow them all because they're really great and helpful in NodeBots and hardware in general. And yeah, thank you. Yay.